Assalamualaikum to our doctor. My name is Faiz bin Juny. My group have been do the project of the design of image enhancement algorithm for tuberculosis detection. In this group, we have two group member, which is Muhammad Hafiz and Muhammad Hadzrami as our leader, and then me as Muhammad Faiz bin Juny. So we will start our presentation. We will go to our slide is table of content of this project. We have introduction, problem statement, objective, SOTA table, tool that have been used in this project, the flowchart, method of evaluating the performance, coding explanation, result of each enhancement technique, and then conclusion. So before we go to our project, we have to know what is tuberculosis. So tuberculosis is a bacterial infectious disease that caused by the Mycobacterium tuberculosis. So it affected majorly. It affected at least 80 the chance is 80 to 85% to affected the lung, but another percent is affected other body part also, such as spine, kidney, or brain. So according to WHO, World Health Organization, in 2024, it is one of the top 10 causes of death worldwide in low and middle income countries. So it has been caused of 1.25 million of death of people that, from this disease alone. So why the early detection is crucial? So early detection is to ensure timely treatment, preventing and the complication and reducing the transmission of the disease. So undiagnosed or delay diagnosis lead to severe health of the outcome and increase the spread of the disease. So our project is we want to assist the doctor rather than replace it. So the diagnosis of the whether the patient have the TB or not is from the doctor. So the final say is from the doctor. So our problem statement in this project is the inconsistent the image quality in TB detection. Secondly, the lack of cooperative analysis of enhancement technique, and lastly, the balancing enhancement feature prevention preservation, which we want to know. We want to don't want to eliminate the tuberculosis from the image. So our objective from this is to we want to identify and implement the different image enhancement technique for improving the quality of TB quality image, personal image. And next, we want to analyze and compare the effectiveness of this technique based on the contrast improvement, noise reduction, and then feature preservation. And lastly, we want to determine the most suitable image enhancement method for optimizing the TB detection. So this is our SOTA table of this project. We have 5 literature review from 5 different sources. From the author, which is the Majid, Mishra, Alua, Mayowa, Susilo, and Wahyuno, and then lastly Gashmat. So from this, we can look this data we selected from the highest method of their literature review. So for Majid, the highest we is when he combine the Ahi plus Fazi. This is hybrid method which combine 2 or more technique. And then Mishra use the Klahi, and then Alumayowa use unsharp masking, and then Susalo and Wahyuno pun also use the Klahi, and then Gashmat use the median filter to get the highest enhancement technique. So the tool that have been used in this project, we use the Python language, Jupyter as our platform we use to run the coding, and then the Kaggle we get the dataset from. In this project, this is our main flowchart of this project, which is it will start from the input of the TB parcel image. In this project, we running for 100 image, but we selected 3 to show the output. And then we go to the image enhancement, comparison and analysis, display enhancement, analysis result, and then we go to stop. All of this will be do in the coding. So in image enhancement, it will go to 5 separated method we want to try. So first we have the image enhancement, which is AHI. So AHI is stand for the adaptive histogram equalization. So AHI it would by divide the image into small or region, or we call as tiles, and applies the histogram equalization to each of the region independently lah. So this enhance the local contrast, making it fine detail of the TV bacilli more visible. Next, you go to the image enhancement sigmoid. So sigmoid mapping applies a non-linear transformation to the pixel intensities. It will influencing specific intensity range. So it use a sigmoid function to adjust the brightness and the contrast of an image, and enhancing the edge and detail of the image. Next, we will go to the image enhancement, CLAHI. So CLAHI stand for the contrast limited adaptive histogram equalization. So how it work is by CLAHI will is an advanced version of the AHI that limit the contrast amplification in each style to prevent noise over enhancement. So it improve local contrast while controlling the noise. Next, we will go to the unsharp masking. So from the name, we can see that it will sharpening the image without sharpening the image by substituting a blur version of the image from the original. So this will enhance the edge and fine detail. And next, we will go to the median filter. So median filter it will reduce the noise by replacing each pixel value with the median value of the neighboring pixel. So effectively remove salt and paper noise while preserving the edge of the image. So from all of this, we can see it will same start. It will go to start, and then it will go to the median filter, and then output of enhancement technique, and then it will stop. And then in this project, method of evaluating the performance of the image enhancement, we use three, which is first we have the peak signal to noise ratio, PSNR. Will measure the quality of the enhanced image compared to the original. And then we have the structural similarity index measure, SSIM. It will evaluate the similarity between the original and then a processor's image. It will consider from the luminance, contrast and the structure. And then we will go to the entropy, EN. It will measure the amount of information or detail in the enhanced image. Next, we will go to the coding explanation. I will pass to the Muhammad Hafiz to present of it.
Thank you, Faiz bin Juny, for the wonderful explanation. My name is Mohd Hadzrami. I will continue my part in my project. Okay, firstly, I will explain a little bit about the code for our project. Okay. First, this part of code we will initialize the function or the import many important things so that the code will run perfectly. Then we go to the function to display an image where its quality matrices. Okay, we know that our project use evaluation matrix such as PSNR, SSIM value, and entropy value. Next, this part of coding will load the image into the coding. Okay, this is the directory path that I set from my document to put the image inside the coding. Then ensure image is loaded correctly. Okay, this is a question part only to check if the image are uploaded or not. Then we go to the function to apply adaptive equalization AHI using CLAHI. This is our first method of our image enhancement. Next, we go to the function to apply sigmoid intensity mapping. Later, it will go to the function to apply contrast limited adaptive histogram equalization, or the synonym is CLAHI in a lab color space. And then the coding will go to the function to apply unsharp masking sharpening. Later, it will call the function to apply a median filter for noise reduction. Later, it will function to evaluate image quality using PSNR, SSMI, SSM and entropy. This is the calculation part to calculate the evaluation matrices. Okay, before you doctor being mistaken, our coding is every method the input is the original image. We not this is not a continuously image being processed from one method to method. Every method the input all the method the input is same, which is the original picture. Then we go at the define parameter for each enhancement method. For every method we have 5 methods. Every single method we divide by 3 different parameter to show to make sure that we have a different output, so that we can make a comparison. Then we store the result from comparison and apply each enhancement method with a different parameter and evaluate performance. Next, the last part we are compute evaluation matrix, display the enhancement image and store result in the table format. Then later we print the result. Okay, I can as you can see here, this is our output. For later I will explain more about the output in the slide presentation. I will just show you around. The output will be a comparison in a table format. Alright, I will continue my part by explaining result of each enhancement technique. Firstly, I will show the example of output from 3 image. Okay, from here you can see that the input is 3 image, and every 3 image will go to the 5 method that we use in this project. We can see there's every image have 5 output, so that we can make a comparison with a different original image. Okay, from the coding, okay, this is the original image that we use in this coding to make the enhancement using 5 method with each method have its own different type of their parameter value. Firstly, this is adaptive histogram equation here. We can see here, we can see the 3 output, very minimal differences. We for the parameter that I changed is first clip limit, so I set to 1, 2 and 3. The title grid is the same, and we can see the output value for the evaluation method. From here, it's observed that increasing the clip limit reduces a PCNR and SSRM but increases entropy. This indicates that higher contrast enhancement may introduce noise, leading to a lower similarity to the original image. Next, I will go to the sigmoid mapping. Sigmoid mapping was tested with 3 different gain value, 5, 10 and 15. The result as follow. Lower gain 5 result in the higher PSNR and SSMI, maintaining a close resemblance to the original image. Higher gain values drastically reduce PSNR and indicate a loss of similarity due to the excessive intensity transformation. Then we go to the Clahe, which is a contrast limited adaptive histogram equalization. Clahe was implemented with a clip limit 1, 2 and 3. The results are displayed in the table. Similar to Ahe, increasing a clip limit reduce result in a decrease in a PSNR and SSMI with an increase is entropy. Alright, move to the next slide. Unsharping masking. Unsharping masking was tested with a sigma value 0.5, 1.0 and 2.0. A sigma value of 0.5 yield the highest PSNR and SSIM, meaning that moderate sharpening preserves more detail while avoiding excessive noise introduction. Next, for For the median filter, the last method that we use, okay, the median filter was applied with a kernel size of 3, 5, and 7. The result can be summarized in the table. Larger kernel size led to a decrease in PSNR and SSIM, suggesting a trade-off between noise reduction and detail preservation. Okay, next I will go to the best method. Best method for each method. Okay, go to the next slide. Based for my analysis, unsharping masking with a sigma 0.5 and strength 1.5 is the most effective method for image enhancement, provide a balance between noise suppression, sharpness, and image quality. The method ensures that edges remain sharp while preserving the natural look of the image. For a noise reduction, median filtering with a kernel 3 is highly recommended due to its ability to effectively remove noise while retaining structural integrity. Lastly, if you want to a contrast enhancement is required, Clahe with a clip limit 1.0 is more preferred method as it improves local contrast while avoiding the over enhancement issue seen in Ahe. That's all for the result. Now I will jump into the last part, which is conclusion. Okay, for the summary of my project in this study, a various image enhancement technique were evaluated to improve image quality. Each method has its own strength, with some excelling in sharpness enhancement, noise reduction, and contrast improvement. The effectiveness of this technique varied based on evaluation metrics such as PSNR, SSIM, and also entropy. The result highlight that selecting the appropriate enhancement method depend on the specific requirement of the task, as different techniques serve in the different purpose in image processing. That's all for us. Thank you.